Hello everyone, and welcome to my talk on Perl in 2025. First of all, some introductions. I am P. Evans on CPAN. I've written some modules that you might be familiar with. I also currently maintain a number of core modules, things like socket and listutil, which you may well not use them directly, but they probably appear somewhere in your dependency tree. I'm a Perl Foundation grantee. I have completed a project for them to write the module Future Async08, which is a module I shall be talking about more in a moment. I am a regular on IRC, in particular in Freenode and irc.perl.org. I get a good feel for the sorts of people who are around in the community. I meet a mix of new people, experienced developers, anyone in between really. I get to see a lot of things that people are working on, see the kinds of problems that people come up against, get into a lot of discussions about the sorts of things that might be added to the language of Perl in order to help these people. So at the end of 2020, I wrote an advent calendar, and the subject of that was how it feels like to be writing Perl in the year 2020. I talked a bit about signatures, I talked about the is-a-operator, and I talked about some of my syntax modules. So here's a URL to that. Now hopefully by the time we upload this as a video, that will be a real clickable link somewhere in the description, but I will pause here for a moment to let you write that down just in case it isn't. So signatures were added in Perl 5.20 by Dave Mitchell, and these follow the observation that basically every function takes a list of arguments and you normally uses the list unpack syntax to assign those into some lexical variables. With a signature you can just put those as parameter names at the end of the function name. Now on the surface it's just a fairly small neatening of the syntax, but it kind of helps to hide the machinery going on here. Especially for smaller things like little code refs that get passed around. It's just a little bit more concise, a little bit neater, but at the same time more readable than any of the alternatives you might otherwise be tempted to write. The is-a-operator, which I added in Perl 5.32, follows along a similar theme of trying to hide bits of machinery. So before that, if you wanted to test if a value is an instance of a particular class, you typically call the blessed function to see is this an object at all, and if so I know it's at least safe to call the is-a-operator, the is-a method on it. So there's a CPAN module called safe is-a that tries to make that thing a little bit neater. I took some inspiration from that and from other places, and I implemented is-a as basic operator syntax in Perl 5.32. It's nothing particularly groundbreaking, but it's just a little bit shorter, a little bit neater, similar kind of idea. So let's consider some exception handling. Now typically in plain Perl you might use a block eval like this. Now there's a lot of machinery noise in here. We have to remember to return a true value like 1 at the end. We have to remember to pull out the value of the $@ variable just in case another exception happens in between and we overwrite the value of it. It's also not very flexible because we can't put a return inside that eval block. It instead makes the eval itself return that value rather than the containing function. So I wrote a module called syntax keyword try, which tidies all of this lot up. That provides two new keywords, try and catch, that basically make this logic a lot neater. So the catch block down here creates a new variable for you, so you don't have to worry about the $@ variable. It's also safe to put a return statement inside that block, because that's implemented properly and it makes the whole containing function return the value rather than just confusing the eval block. So it's again just a little bit tidier, a little bit neater. The async-await module, now I mentioned that earlier, that is another one that just tries to tidy away frankly quite a lot of noise. So here is a typical piece of code that you might write using just plain futures. Now don't worry if you're not too familiar with futures and asynchronous programming, just kind of accept there's a lot of lines of code here that actually doesn't do very much, because when we use async-await, that's all the behavior that's all there is here. It's much shorter, much clearer, much neater. You can look at that and instantly see what's going on here. We're just checking if a value is defined, and if not, we're awaiting on this read method. As compared to the previous code, it's a lot shorter, a lot clearer. Now, object systems. Now, there's quite a number of those already on CPAN, and all of them try to do a certain amount of neatening up and tidying of code. So in plain Perl, if you were wanting to write an object class, typically you would have to call the bless operator yourself and return this blessed hashref containing your instance data, your keys. You then use the keys in this self hash to store all your various bits of data. It's prone to things like typos and key names. It's prone to clashes of key names between subclasses and things. You can forget to pull out self out of the arguments in one of these methods, and really just there's a lot of things that can go wrong because you're writing a lot of this low-level machinery yourself. So I wrote this module called Object Pad, which tidies a lot of this lot up. It provides these keywords class, has, and method. Between those, they allow you to implement object state stored in these instance variables here that look and feel a lot like lexical variables. So there's no chance of typos in them. There's no name clashes between subclasses and things. And between them, they just tidy away all of that machinery. You don't need to care about it. So fewer bugs, shorter code, more readable code. Now, ObjectPad is inspired by an idea called core by Curtis Poe, otherwise known as Ovid. There's a link there to the wiki describing all of that. Now, core is very much an idea, a design, a set of thoughts by Ovid, and ObjectPad is an implementation that is sort of loosely based on those ideas. So there's some slight differences, some slight variations, but generally his ideas inspire my implementation, and then I go off and implement things, give him some feedback about what works, what doesn't. So it's kind of a two-way process. Now, Ovid actually did a talk earlier today at FOSDEM about the subject of his core design. So if you haven't already seen that, I suggest you look that one up afterwards and go and have a look. So towards the end of the blog posts, I observed that a lot of these syntax modules can actually be combined together. So for example, we can put a return statement inside a try block inside an async sub, and that just works as you'd expect. You can also use async method together and create asynchronous methods on object classes. Now, this particular example here has what's that, 5 words, 2 operators. That's actually performing the exact same logic as the very first case that we saw with this entire 5 lines worth of code. It's immediately clear and obvious by just looking at that second one exactly what's going on here. Whereas you look at the first one, it's prone to a lot of mistakes. You could have typos in the key names or whatever, and just overall here it's a huge neatening up of that code. So the very final day of the blog post, I tried to look ahead a few years to consider what sort of Perl we might be writing in the year 2025. So let's have a look at some of these ideas now. Now, some of them are fairly complete and we could just basically implement them as they stand. Others are a little bit more vague, need a bit more discussion, more thinking around them. Some of them could be implemented as CPAN modules on their own. Some of them really do need to be implemented in Perl core itself. In a similar theme to what we've already seen already, many of these ideas could be combined together. So while they are useful on their own, they gain a lot of their power by having all of them around and being able to combine them into particularly powerful combinations. So I'll be going sort of backwards and forwards between some of the ideas and revisiting things here and there. Overall, feedback very much welcome because, as I said, some of these ideas are a little bit vague. Some of them still need a bit more thinking about them. But with that in mind, let's begin. So first of all, I think we're going to have to lose smartmatch. Now, smartmatch was a thing that was imported from Perl 6, as it was known as, now called Raku. Now in Raku has a real typing system, so values know what their type is. Specifically, they know if they're a string versus a number. In Perl 5, it's a lot less clear. Values could start off being a string or a number, but maybe they'll end up being both at some point, which means that smartmatch isn't very easy to use because it's unpredictable. For example, here, the value 5, it matters depending on whether one or both of these is a string. And it turns out that Perl tends to use numerical comparison unless both of the values are strings. the rules don't stop there. There's rules about array comparisons and hashes and even code refs, and is the current environment an even number or not? I mean, is this a question that even makes sense? I don't know. So all of that's a shame, really, because smartmatch is used by the given when syntax. And the idea with that is that we quite often want to look at a given value and see whether it matches a bunch of different cases. But that's implemented using smartmatch. So even though this is a useful idea, it gets very fragile because of the underlying fragile unpredictability of smartmatch. So I could imagine a new syntax that I'm calling match case. So again, that typical example of code we saw earlier, we could imagine writing this form to say match this variable using this string equality operator against these various cases. So the programmer has told us we are using the string comparison operator, so there's no ambiguity here, there's no guesswork about are we doing strings or numbers. It's completely obvious. Or they could have chosen to written the numerical equality operator instead. Now there is a module on CPAN called switch plain that implements this as two different keywords, switch and nswitch. Now that's okay, but it doesn't combine very well with other operators. For example, regex matching, whereas if we use match case, well, we can just specify the regex operator in there instead. Or the isA operator, and we can just choose based on the kind of object class that we've got, which block of code we're going to do. An extension of this idea is that we could perhaps consider putting multiple case values under a single block. And that would be basically equivalent to just testing multiple values using the OR operator. And I think that would be a reasonable extension of this syntax. But I don't think we should go too much further with the whole set of rules that smartmatch has with things like arrays and hashes and code refs and all this lot. So some comments here. Now, firstly, you'll notice that all of these examples only use literal constants as case values. There's no variables here. Initially, at least, I think that's all we'd want to support, because if that's the case, then the compiler can check at compile time that all of these values are unique. And the compiler can analyze these values and form a more efficient dispatch logic than, for example, just doing an ordered list of tests. So if you supply a lot of numbers or a lot of strings to be checked, then maybe it could implement that with some sort of binary search or something. But in order for all of those things to work, it does need to be restricted to a fixed set of operators. In particular, I think only the ones that we've already seen here. So string and number equality, regex testing, and object isA. I think that's all we'd really want to be able to support, at least initially, until we have a good working implementation. But I still have some open questions about this as a syntax. So, for example, how do we handle undef? Now, given when is happy with this because the smartmatch operator considers undef to be a distinct value from anything else. And so given when can just look at that and say, yes, we can distinguish the undef case from the empty string case. But if we're saying that given that match case uses just the plain string equality, then we have a problem here, because both the undef value and the empty string compare the same according to their eq operator. So I maybe could consider that we would handle undef as a special case here. So we could say that if you have undef as a case label, then we want to check that one first to see if it's undefined, it's definitely this thing. Otherwise, all of the other case labels know that they are defined, and therefore the empty string, if it appears, is going to be handled differently. That's one thing we could do. Another idea I have is that maybe we need a new operator in Perl. And I would like to spell this one EQU, short for equal. Keeps the scheme fans happy, if anybody knows the scheme. And this one would be a little bit like string the regular string equality comparison, but it would consider undef to be a unique different value that is different from any possible string, including the empty string. But otherwise it just behaves the same as string equality. And of course it would have no need to warn about undef at that point, so it would never raise a warning, and it would always consider undef to be different from the empty string, and otherwise just behaves the same as string comparison. It might be a bit of a slippery slope towards the idea of a smart match, but I think in this case it could probably be justified, because as well as strings, then obviously we have the idea of number comparison. And between these two, I have seen quite a lot of code around, especially on CPAN, that either takes special effort to compare undef differently to defined values, or happens to have a bug because it doesn't consider undef separately, and really it ought to. So actually there's a lot of logic around that could be either neater or have fewer bugs in it if these operators were to exist. So I think there's a reasonable case for trying to add these to the language as well. Now another open question I still have about match case is, what do we do about ranges? Because if we're saying that we're going to allow a list of multiple values here, for example all of the digits from 2 to 9, then we'd be quite tempted to allow the ... operator to just list those as a short sequence. And maybe then the implementation of those could be done a little bit more efficiently, where internally, rather than listing those as all the different values individually, we just implement that as a range test and we'll say, is it between 2 and 9? But then we'd be tempted to say, well, would we allow these kind of open ranges where we only put one of the endpoints in, and so could we check if it is 10 or above with no upper bound? That's some slightly weird syntax that you wouldn't write anywhere else, but maybe we'd allow that in a case label, possibly. But at that point, it becomes not really like just an any test. Because imagine, for example, what do we do with non-integers? So in this example, the value 2.5, does that match this case label? Well, it's clearly between 0 and 9, but it's not any of the single-digit integers. So does it match? I don't know. As I said, it's an open question. I could be swayed either way about any of this. Thoughts welcome. Related to this is the idea of these one of any value tests. So earlier I presented this piece of code as being equivalent to the multiple case values, and now many people would look at that and realise that could be written using the any function from listutil. It looks shorter, it looks neater, it's a bit more concise as to what's going on, but it's actually much less efficient at runtime, because this block in the middle here is actually an anonymous function that gets invoked for each value, and that is actually quite an expensive thing to do. So I could consider having any as kind of a basic operator in the language. So even though it would be spelled identically to using it from listutil, it would be implemented internally much more like grep, where this block here is just a basic expression. It's not a complete anonymous function, so it's much lighter weight to implement efficiently. And while we're at it, we could probably consider the all operator just as easily, and the none and the not all, and maybe we'd add a few more of those things from listutil. We'd have to see what's reasonable, but I think that would be a nice idea. Related to these, people often ask for an in operator, because really what we're doing here is asking, is this variable in the list of 2, 3, 4 on the side here? Many people say, well, could we write that using in? No, we can't do that because of basically the same problem as we have with smartmatch. Does that perform a string or a numerical comparison? Instead, though, I think we would quite like in as a metaoperator, a thing that operates on operators. Because when we write this down using the any, we're still writing the numerical equals operator here as part of the expression. So I think much like the match case syntax, I think it would be nice to get the programmer to tell us the comparison operator for the in operation. So maybe we'd write something like this. Now that syntax looks kind of messy because you've got this infix operator sitting here in parentheses next to another operator, and the whole thing is infix in between these other two things. It's I don't know, it's messy. I don't like the syntax. Maybe we use angle brackets instead. That feels a little bit like C++. Maybe we'd borrow the colon operator from the colon syntax from match case, and we'd write that in this way. I don't know. Still looks a bit messy. I'm kind of unconvinced by any of these ideas, to be honest, which is a shame because I really do want this ability in the language. I think it would be a very nice, very powerful addition. I don't know how to spell it. Because if we had it, then as well as numerical comparison, we can do string comparison, we can do regexps, we could do class tests maybe with isA, and of course let's not forget our new defined versions of these operators as well. And so suddenly just by having that in operator, we've kind of, well, that in meta operator, we've suddenly got effectively 6 new actual operators here. Let's find a nice way to spell that. So another thing that I think needs a better name. So signatures are sort of like a list unpack in that if we were to write some signature parameters to a function, it's sort of like just performing a list assignment into a list of those variables from the list of values passed into the function. But there's really more to it than that, because the signatures will complain if there are too few arguments or there are too many arguments. It will check that kind of thing. Similarly, if we were to provide some default values for these arguments, then there's some logic to apply the default value or not, depending on whether one was supplied in the input list. So I could imagine a new kind of operator. For now, I'm going to call it bind. Now, this bind operator would behave exactly the same as signature assignment, but it could take any expression on the right-hand side. So in this case, we're going to take 2 and optionally a third value and assign them into these variables. But unlike regular list assignment, it will complain if there are not enough or if there are too many values. Now, this spelling might be hard to implement. It might be considered ambiguous, not visually distinct enough. It's perhaps not right. So maybe we should do this with a new keyword like let. But I do think we do need something like this, because I think, given the way that signatures work, I think this should be the kind of preferred way for list assignment to work. Because generally you do want to know if you've got too few or you've got some spare values left over. And I think it would be nice if list assignment actually complained about that. Perhaps at that point, if it's just a new keyword name, we'll just implement that as a CPAN module for now, at least to experiment with the idea. Because signatures, for example, might gain the ability to do named parameters with this sort of leading colon syntax here, where we're saying we expect to receive some named parameters to this function. And so obviously our let operator would be able to handle that just as easily. In cases like that turn up a lot in existing code, and typically people use something like a hash slice syntax to unpack that. And so I think this let syntax would make those things look a little bit neater again. It's not hugely groundbreaking, but again, like signatures, it's a small neatening up that I think could make a difference. At some point, signatures might gain isA assertions, the idea that the signature will also complain if the types of the values that are passed in are not right. And so obviously we would implement that in the let syntax just as simply. I think that would be a nice idea. Now, if we've got this idea of a let list binding that could succeed or fail, then we'd be tempted to consider something that does so conditionally. So you can see here I really don't have a good name for it. Again, suggestions welcome. But the idea here is that rather than throwing an exception if the assignment fails, instead it just returns false to say it couldn't assign the values. or if it succeeds, then it returns true. So that means that this whole block is now conditional on whether or not that unpack happened. But if not, it doesn't throw an exception. It's also very useful for while loops because here, for example, as while we keep getting values out of this next method, then we'll keep succeeding in being able to assign them, and the while loop continues. As soon as we don't get a value, then it returns false and the while loop stops. So just to explain that in a bit more detail, in case you're unclear, the maybe operator is going to fail if it doesn't have enough values, but it's going to succeed if it gets enough values, even if the values themselves are false or undef. The success of the assignment operator, the return value of that, depends on the ability to assign the values, not the values themselves. Now, maybe that notation is a bit non-obvious, a bit contentious. This is definitely in the area of needs more discussion. So, yeah. Another thing that needs a lot of discussion is typing systems. There's a lot of things that people might mean when they ask for a typing system. Sometimes they want static assertions. They want the compiler to look at the program and tell them at compile time, this program can never work. Other times people want dynamic assertions about the values that the program is operating on, where the program's syntax may be fine and understood, but at runtime when we inspect the values we find that something isn't right here and we can't actually do anything. And yet other people want typing systems as kind of performance hints, where you can put types around your code and then it happens to run more efficiently at runtime by making assumptions based on those types. So we've kind of got these three different ideas for what people want as typing systems. And the problem is some of these things kind of compete with each other. And it's hard to cover all the bases at once. You kind of have to pick the kind of thing you want to do. So firstly, I think, well, Perl is a very dynamic language. And I think there's no point trying to put lots of static checking into Perl. That's not really going to work. Secondly, I think we already have quite a few dynamic type checking things going on anyway. And I think, you know, if you wanted high performance fast loop code on native types, then Perl really isn't your language. So I think the thing to do is some sort of dynamic typing system. Now, the way I could imagine that working is that currently if we say that at some point functions are going to take these is-a assertions, then we could extend that to a more general is notation, where we can assert on things more than just object classes, but kind of general conditions as well. So here, for example, we're checking that a number is not negative. But those type constraints do need to be fairly general and customizable and user definable in order to be useful. And so once we can put them on signatures, then fairly obviously they would also apply to the list bind operator, the let. We could consider those on match case as well, for example. We could probably put those on lexical variables. We could put those on slot variables of object classes. And generally start scattering them all about the language in order to provide a certain amount of type assertions at runtime. And I think that would also add a lot of power to the language. Slightly related to that is the idea of multiple dispatch. So sometimes you end up writing a function that basically does entirely different things based on its arguments. Now you could write that with if-else like this. Or we could use match case, perhaps with the is-a tests or the is or whatever. But some languages define a thing called multiple dispatch, where you can define the same named function multiple times and use the type assertions in the signature to let the runtime work out which particular instance of that function you wanted to call at any particular time. So we could imagine this multi keyword to put in front of sub for doing that. Or we could put multi in front of method, and you could do multiple dispatch on methods. And you'd probably want to make sure you can also combine that with multi-async method. And that would be particularly powerful as well. So overall here we have quite a lot of additional syntax that would be nice to add to the language. We've got match case, we've got the defined sensitive equality operators, we've got any and all as real syntax, we've got the in metaoperator, we have this generic list bind let expression, we have type assertions using is, and we have multiple dispatch using multi. So that's quite a lot of things that are nice ideas on their own, but most of them work best combined together, because we have a lot of these new operators like is a and the defined equality operators in a lot of new locations like try catch, match, signatures, multi-sub, that sort of thing. And if we were to add all of these, we do have a nicely big powerful language. While we're at it, I think there are a lot of things that are currently CPAN modules that are fairly stable and could probably be moved to core. So try-catch notation, for example, that could probably end up as use feature try. Object pad or something similar to it based on the core design should end up as use feature class. So if we're going to move things into core, then we can use the use version syntax, which we've had in Perl for a very long time. You can use v5.10 and it turns on features like say and state. You can use 5.16, it turns on things like fold case and the current sub shortcut. These are things we've had for a very long time. So there's no reason to think that perhaps by maybe 5.36 or so, we've got this try catch and we've got match and we've got the in metaoperator and we've got let. And maybe by 5.40 or so, we've got this class notation and maybe we've even got types. And at that point, maybe we just call it use v7. I think that'd be nice. I'm now going to hand over to the live QA. Thank you.